Hello everyone, welcome back to the next video. In this, we will look at a new toolpath called as Contour, 2D Contour to be more specific. So we have an option called as 2D Contour. With this, what we will do is we will try and remove out the excess material on the sides of the component. All right. So for this, let's change the tool. Again, like I said earlier, very similar looking dialog box for the remaining tool paths as well. So first and foremost, we'll change the tool. We'll come down to milling tools metric and we'll filter out only flat end mills and we can select 8 flat end mill. So in my previous video, I was talking about presets. So this is where we have all the presets. You can notice Fusion has gone up to the extent of creating the various presets for different materials, aluminum, brass, copper, low carbon steel, high carbon steel, and so on. Assuming we are machining a piece of aluminum, we can take up aluminum finishing in this case. And you can notice the spindle speed is 12,000 RPM, cutting feed rate is 4,000 mm per minute. We can go ahead with that, select. Let's move to the next tab called as geometry. In this, all we'll have to do is select our contour. What I'm doing is I'm selecting the bottommost contour so that we don't have to alter the heights. If you select the topmost contour, the tool will only run there. So now that we have specified the bottom contour, the tool will run around and below as well. All right. So what we can also do additionally is under the heights tab, we have, you can notice we have clearance height, retract height, feed height, top height, bottom height. We'll get into the details in the upcoming videos. But for now, I would like to focus on bottom height. You can notice bottom height is the contour that we have selected. What I'll go ahead and do is I'll add a minus 0.5 mm so that the tool comes a little bit below so that our part is finished per se. And in the second setup, all we have to do is facing. Okay. And we'll not make any other changes. We'll see how the tool path comes out. And from there, we can go ahead. Okay. Give it a couple of seconds and Fusion has created us the tool path. All right. So now you can notice now we have the toolpath. So what we have here is let's simulate it and then understand how the toolpath operates to get a better understanding. Once I play, you can notice I'm only simulating the contour toolpath. Starting the contour toolpath is very good. You can notice I slow it down a bit so that we can study it a bit. And as it comes to the semicircle half of it, you can notice the tool is digging in completely. This is good if your tool that you're utilizing is of good grade and good quality. Say it's a very basic standard end mill, then you will have to probably alter the cutting parameters. So alternatively, what we can do is we'll go ahead and let's add multiple depths just to increase the tool life. Yes, it does take away a little bit of cycle time, but that is still negligible. So we'll go down to multiple depths and we'll come down to probably 0.8 mm per step. Okay, 0.8 mm roughing step down. You can click on OK, allow it to generate the tool path, and you can notice now we have a much more effective tool path in the sense that the tool is not undergoing shock in any way and it's not taking in sudden loads. Apart from that, yes, the tool path is good to go ahead. I'll speed it up a little bit and you can notice there's not much load acting on the tool path as well. Tool. So this is nice and clean. As we come to the end of it, you will notice the sharp corners of the part is also ready. Right. So, so far so good. We can employ the same option even in this inner ID as well. So I'll go ahead, I'll react, double click the 2D contour command. In the geometry section, I'll select this edge as well, the inner circular edge, so that both the contours are machined out in the same toolpath. Okay, we'll just do a quick run through and then we'll close on this particular toolpath and let's focus on the next toolpath. So we are starting off with facing, and then the tool changes to tool T5, and now we have our contours that are being machined out. So if there's any material stock that's left out, in the second setup when we would be doing the facing, these pockets of material that are left out would come off. It would just ideally fall off or it would just get machined out. Yes. So I'll speed it up a little bit and we have this. So all we are left to do is machine out these holes and the counter bores. Okay. We'll look at that in the next video. Thank you everyone.